Alright, Brandon Clayton here, the Algebra Guy. Today's lesson, how to find slope or rate of change when given a table, a graph, 2 points, or a verbal description. So it's all about slope and rate of change today, which are pretty closely related, and I'll talk about that here in just a second. So what are we looking at as far as our TEKS? So when talking about our Algebra 1 STAR test, here are the two TEKS, 3A and 3B, determining the slope of a line when you're given a table, graph, or 2 points, and an equation, whether they're written in the slope-intercept, standard, or point slope form. So we're going to look at how to find the slope in any of those forms, and also in 3B, calculate the rate of change of linear functions represented by tables, graphs, algebraic context of mathematical and real-world problems. So what's the difference between slope and rate of change? Well, really, rate of change is talking about when you have units involved, like in this graph here. Notice that we're dealing with height and feet. So we got a young man flying his drone, and we're talking about how high it's flying. At what rate is it flying? So how many feet per second? So the feet per second part makes it a rate. So when you have two different units being compared like that, miles per hour, feet per second, anything like that, how much money you make per hour, those are all rates. Now the slope is just the number without those units attached to it. So they're pretty closely related, but let's jump right into it. So I'm going to start with this graph here and ask you to find the slope or rate of change, which is going to be the same number with or without the units. So what is the slope? How do I deal with this with a graph? Well, it's pretty simple when you have a graph, because all you need to do is find out how quickly your y values are changing in comparison to your x values. And in order to do that, we have to find 2 points. So let's compare 2 points here. So let's find 2 points. So would this be let's start here. This is a good point to use. Why is this a good point? Because I have two integers that I can look at. This is a 0 on my x-axis and a 4 on my y-axis. So I know 0, 4 are two coordinates and a point, if you will, that I can use to start to think about what the rate of change is here. Let's see. If I try to take this point here, it'll be in somewhere in between 0 and 1. So you don't want to use that one. This is not an integer either. So I'm going to keep that's not an integer. We could say it's about a half, but you do not want to guess here. So let's find one that's pretty clearly identified, and it looks like right there. And if I keep going, there's another here. So I only need 2. I'm going to take the closest 2 because by doing so, it'll save me some simplification of the fraction later on, if there is a fraction. So let's take this point. This point is 3, 12. 3, 12. So one of the ways you're taught to find slope is using the equation for slope, which is y2 minus y1 divided by x2 minus x1. And all that's saying is identify 1 point. Let's say we call this point right here our x1 y1 point. So we'll say this is our x1 y1. So this is our first point, and we'll call this our second point, y2. So it actually doesn't matter which points you choose to be 1 or 2, as long as you make sure you keep both coordinates. Like both of these have to be a 1, both of these have to be a 2, or both of these have to be a 1, both of these have to be a 2. So as long as you do that. Now if we use this way, we could just simply say, let's take this first one here. So this is our first one, this is our second one. So we'll do 12 minus 4, because we're subtracting 12 minus, this is our y2 and our y1. Here's our y2 and our y1. So we're subtracting those, and we'll do our x2 and x1. And that'll be 3 minus 0. Well, 12 minus 4 gives us 8, and 3 minus 0 is 3. So 8 over 3. Now that's the slope. Now if you wanted to make it into rate, guess what we have to do? Just include the units. So 8 what? Well, it's 8 feet. 8 feet for every 3 seconds. So now if we can put some context to it, we can say that this drone is rising at a rate of 8 feet for every 3 seconds. Sounds pretty intelligent to me. So I'm gonna go with that. So what we did is identify 2 points, and I put 2 points here because we're asked to use a table and be able to identify the slope and rate of change given a table or 2 points. But they're the same thing. When you have a table, you're finding 2 points. So whether I've written the points in a table or I wrote the points like this, so whether I'm given 2 points like this or write them in a table, you're doing exactly the same thing. So I wanted you to see that. Now, you could work it out this way using y2 minus y1, x2 minus x1. You can put in your calculator to make sure you got it correct. But one of the ways I really enjoy working it, and a lot of my students do, is simply looking at the relationship between 4, 12 on a table and 0 and 3 on a table. What do I mean? Well, I just draw this little angle looking piece here because I'm asking myself, how much did I go up from 4 to 12? Well, I went up 8. Well, so I know that that's my change in y is 8. It went a positive 8 up. Well, over from 0 to 3, what happened? It went up because I'm from 0 to 3. How much? 3. And there it is. We got the same answer. And it saved us a lot of the steps here. So you pick. I'm going to give you the choice. But I prefer to use a table when I'm given 2 points and just do it that way. Now, one last way you want to think about using when you have a graph is simply counting on the graph itself. So I could have literally gone from this first point down here to this point here by counting. I could say, let's use what's called a slope triangle, and I would count up, and I would say I went up all the way here. So how much did I go up? Well, I'll say I went up from 4 to 12. I went up 8, positive 8, and then how much do you need to go over? So see the triangle that we're making to get to that point is right there. So how much do we need to go over? Well, we need to go from 0 to 3. And notice that the unit increments are different, right? Because we're counting by 1s here and 2s here. So don't be confused. Another big mistake students make is they count the squares. They say, I went up 1, 2, 3, 4 squares. No. We're looking at the actual units that were being measured in feet. So these are 2, 4, 6, 8. So make sure you're looking at the actual numbers to get the right answer, because you'll see in our STAR problems today that they're testing you on that. Are you identifying the increments that are being counted, the actual units, and not just the squares? So we'll say 8 over 3 is our rate of change. So there's a couple ways you can do it. Now, what if you chose this point? Would you stick at the answer? Absolutely. So if I chose that point, that means I'm going from 4 to 20, which is up 16. So I went from 4 all the way up here to 20. So I have a triangle there. And then I went from 0 all the way over to, what is this? 6. So 6. So 16, I end up with 16 over 6. Well, I thought our answer was 8 over 3. It is. They're both the exact same, aren't they? Because these are equivalent fractions. Because if I divide both the top and bottom by 2, guess what I get? The same thing. So that's why I said it'll save you time to find the 2 closest point. Not necessary, but just something that's food for thought you should know. All right, let's try a different one. What if you have this graph? Pause it here and see if you can find the slope or rate of change. All right, so I'm going to first identify 2 points. There's a good point, and there's a good point. What makes it a good point? Because both coordinates are integers, 16 for that point and 3. It's not something in the middle of 2 integers that I have to guess as a fraction. So I'm going to use those 2 points. I just randomly chose them, but you could have used any of these points, right? Actually, some of the best points here are your intercepts because there's a 0 in it. So actually, I'm going to use that. Now think about it. So I'm going to use some of these small numbers, including the 0. So let's look at that. I'm going to start with this point here on the bottom, and I'm going to count how much I need to go up to get to this next point. So let's look. We're counting by 2, so I got to be careful here. This is 2, then 4. So it looks like I went up 4. And how much do I go to the left to get to this next point? We're counting by 1, so I'm going 1. So I went minus 1 because I'm having to go to the left. So that just told me what my slope was. It's positive 4 and negative 1. So in other words, it's a negative 4 over 1, or also can be written just simply negative 4. Now notice I didn't have to use my table. I could have plugged in these 2 points. I could have said that this was, let's go ahead and do that. I could have said this was 7, 0, and this is 6, 4, 6, 4. And then when I evaluate this, I can see that I'm going to have to go up 4 and down 1. And look, we still get the same thing. And you could have used y2 minus y1 divided by x. You could have done that. You could have said 4 minus 0 divided by 6 minus 7. And gotten 4, 6 minus 7 is, as you can see, all these ways work. And you could have used 2 points, which we did after I put them on the table. So either one of those ways would have worked. Now, what if I wanted to have a rate and not just a slope? So this is the slope, right? -4 is my slope, or -4/1, but most of the time we don't write the 1 on the bottom. We just simply say -4, because -4 divided by 1 is -4. But if I wanted to represent it as a rate, of course I'm just going to add my units. So instead of -4, just -4, we're going to put the y value, which was feet. So I'm going to say it's going down 4 feet for every 1 second. So it's going down 4. This is the down part, the negative. It's going down 4 feet every second. So that's how you would think through that as a rate. I do want to just point out, when you're dealing with a negative, the number of ways it can be represented, as you see up here. We can say -4 over 1. That's the same thing as saying 4 over -1. And it's also the same thing as simply saying -4 over 1, where the negative is out here on the fraction, and it's also the same as -4. So all these are exactly the same. If you had a question about that, you could literally put in your calculator and divide -4 divided by 1, 4 divided by -1. You can put all these in the same way. You're going to get the same answer to show that. So keep that in mind as we move forward. Now, find the rate of change if you got 2 points on the table. Now, we've already done 2 points, so it should be pretty easy. And we've done the table. But to make sure we've done it explicitly, let's go ahead and work these. I will pause it here and see if you can work through these yourself. All right, I'm hoping that you've paused it already and that you've worked these and you found that this slope for this table, the slope for this table, and the slope for these 2 points. But let's do so just to check our answer. So if I'm looking at a table like this, all I'm going to do is identify 2 points that I feel comfortable working with. Since I know this is linear, it doesn't matter which 2 points, because any 2 points have the same slope. As we saw earlier, it just makes it where I need to simplify sometimes. So I'm just going to pick these first 2 points because they're smaller numbers. And I'm going to look here and say, what's happening with my y from 12 to 15? Well, we're going up 3. So I already know my y value, so I can go ahead and put a 3 here. And my x, when I go up 3, what's happening with my x? Well, it's going up 1. So this is just 3 over 1, which is the same thing as just 3. I don't have any units here, so all I can do is find slope, and it's just 3. What if I'm given 2 points? Well, the same thing. I'm identifying the slope from these 2 points, just like I did on the table. I don't like to see it this way, so I encourage my students to do the y2 minus y1 over x2 minus x1, but I really prefer that students will just put it back in the table because it's so much nicer to look at. So if I drew a quick table here and I put my points in, 1463 and -4, -18, it's a little bit easier for me to see what's going to happen with my points. So these are bigger numbers. I normally get a calculator to work this, but what's going on here from 63 to 18? Well, it's going down, obviously. My goodness, quite a bit. Well, 63 plus another 18. So what's 63 plus 18? It's going to be 178. Is that right? So that looks good. So it's going down 81. Well, when it goes down 81, what's happening with the x during that time? Well, it's also going down. So from 14 to -4, so how much? It's from 14 to and minus 4 more, so it's just a 18. That's kind of funny, those being backwards like that. So down 81, down -18. So -81 and -18. I know that negative divided by negative is a positive, so it's going to be 81 over 18. But I also know that this can be simplified. Now, this is your rate. This is your slope, rather. So this is a fine answer. But I think this can be simplified more because I can see that they both have a factor of 9. 9 times 9 is 81. 9 times 2 is 18. So I can divide 81 by 9. So 81, if I divide it by 9, that'll give me 9. And if I divide 18 divided by 9, that'll give me 2. So it looks like we have a slope of 9/2. Now look at this. At first it looked like the slope, this line was going down. We would have thought this line is going down somehow. But actually, because it's negative and negative, it turned into a positive. So this line is actually going up. So when you count your slope, and actually I'm gonna go back and show that here in a second. Actually, I could do it here. So if you count your slope, if you're going negative and negative, if you had 2 points and you're going down so many and to the left, well, if you're going down and to the left, down and to the left, if you're going negative, negative, look what kind of line you're eventually going to make. It's going to be positive. So that's why it's the same thing as what we've shown before. Negative and negative is going to be a positive. So let's do this one over here. Now I have this one. I have some decimals here and whatever, but I'm just going to pick 2 points. Now the smart thing to do, in my opinion, is to avoid the decimals if you can, just because it's easier to work. They're both going to give you the same answer. So I'm going to choose 10 and 15 and 6, -6 and -4 to find my slope with. So it's going up 5 here. And from -6 and -4, it's going up 2. So now I know my slope is 5/2. So it's that simple. It's the same thing here because they're all aligned, but those numbers are easier to deal with. All right, so here we got some decimals. This just means a little bit more work. If I set this up in the table, it'll be 9, 14.4, and 1 and 1.6. So this doesn't look fun to work. I'll just punch this in my calculator. And that's what I'm going to do actually. So I'm going to leave these numbers here, rewrite them and punch them in the calculator, just because when it comes to decimals, I got a calculator. I'm not going to try to do it by hand. That was another grade where we spent time doing that. But since we have the calculator, let's use it. So I'm going to take my calculator out, and we're just going to punch that in there as follows. So let me rewrite this to set this up. We got our table was 9, 14.4, and 1 and 1.6. So this is our x, this is our y. I want to know what's going on here. So when I subtract, obviously it's going down, but how much? So I'm going to do 14.4 minus 14.4 minus 1.6. So 12.8. It's going down 12.8. And from 9 to 1, hey, that's pretty easy. I can do that one. So we're going down 8. So negative 12.8 over negative 8. Obviously, that's going to be a positive, right? Because you got negative and a negative. And you may see it like that. You may see negative 12.8 over 8 or some equivalent fraction of that. So just keep that in mind, that that's how it looks. Now, if you put it straight in your calculator like this, what would that look like? So let's do this little bar here, and we put negative 12.8, and we put negative 8 here, 1.6. So it just gives us the 1.6. So you could get any of those 1.6, because when you divide this, you get 1.6. So that'll be your rate, or it could be left like this in the fraction. Now, lastly, I want to look at how to identify slope when you're giving standard form, as you see right here. Point slope form tends to be a little bit easier because point slope form, well, we'll look at that with the star problem. It has a point slope form there. But standard form is very, very common when they're asking you for slope or y-intercept. They're trying to get you to see the graph, but they want to know that you can see or transform this so that you can find the slope. Now, typically, students may think of the slope wherever the x is and look at this and say, oh, the slope is 2. Because we get so used to using y-intercept, slope-intercept, and seeing that the slope is here. But it only is obvious when you have it in slope-intercept form, which these are not in. This is in standard form. So let's go ahead and just do the work of solving for y, getting this by itself to do that. So in order to do that, I'm going to subtract 2x. I'm trying to get my y by itself. So I'm subtracting 2x on both sides because that'll get rid of this thing. Now that leaves me with negative 5y equals a negative 2x plus 15. Notice I left that negative attached to that 5. That's another mistake that can be made. So that's a negative 5y. Now I'm going to divide by negative 5 and divide by negative 5. Negative 5 and negative 5 just gives me that y. Now watch this. This negative 5 is dividing this negative 2 and a 15. Now it's not important the 15 so much for this particular point since we're looking for a slope. But just know that that 5, you have to divide both of these terms by that. So this negative 2 divided by negative 5 becomes a 2 over 5 because negative and negative gives me a positive. And 15 divided by negative 5 is a negative 3. So this is my slope-intercept equation, and I can clearly see what the slope is, 2/5. Now I couldn't see that in this form, but now I can because we've isolated it. This is a little bit easier because the y is already by itself with just a 1 in front of it, so I need to get rid of this 6x. I'm going to subtract 6x on both sides. That makes this go to 0. Now I'm left with y equals negative 6x minus 2. And my slope, negative 6 right there. So now I can see it. I couldn't see it before, but now I can. Again, negative 4x, or subtract 4x. That leaves me with negative 3y equals negative 4x plus 6. What's my slope? We still don't know. We got to do one more step and get it in slope-intercept form. So dividing by negative 3 here, well, this cancels out. Now I'm left with y equals negative 4 divided by negative 3 is a positive 4 over 3. And I'm still be multiplying it by x. And 6 divided by negative 3 is a negative 2. So my slope here is 4/3. So there you go. You couldn't see it within standard form, but now you know how to take it out or get it in slope-intercept form so it becomes very obvious. All right, let's work through a few problems from the STAR test and how this came up. Now, this comes up quite a bit, so I want to work a few problems to make sure you see this. Please, on your paper, work through these and see if you can get the right answer before I do. All right, what's the slope of this line? So this was a few years ago, right? They gave this problem, and guess what form it is? Standard form. I told you it's a common problem they'll give you to see if you can identify it. Notice they have negative 12 here. 5 12s, 12. They have some answers here that if you glance at it, you may think, oh, that could be it, but we're no better than that. We're going to work it. So we're going to isolate this y, just like we did in our practice problems, by subtracting 5x. That leaves us a negative 12y. Notice again that I'm leaving that negative with that 12. That's negative 5x plus 24, dividing by negative 12 on both sides. Those negative 12s cancel. Y equals negative 5 divided by negative 12 is a positive 12 because negative divided by negative is a positive. 24 divided by negative 12 is a, that's a minus 2. That's a negative 2. And there's our equation. So now we have our equation. We're really looking for what? The slope. So the slope is obvious now because we have it in slope-intercept form. And 5/12 is really what we're looking for. So fantastic job to you if you got that already. If you didn't, let's try this next one. What's the slope of the line that goes through these 2 points? So there's a line that goes through these 2 points, and we can figure that out, right? So pause it here and see if you can get that. Now I'm going to go ahead and work it. Hopefully you've paused it already. I like to pull up a table. Some students use the y2 minus y1, but this just helps me see it better. So I have a 26/7 and a negative 39/12. Now, does it matter? I feel like someone's asking this question. Does it matter which one you put in first? What if I would have put negative 39/12 up here? Would that change the answer? No, you're still going to have the same slope. Whether you start, just like if we had it on the graph. So if we had this, let's see, 26/7, let's say it's up here, negative 39/12 is up here. So whether you start from this point and say we're going down and to the right or up and to the left, it gives us the exact same numbers. This is a positive, then I'm sorry, it's going down and then plus, so that's going to give us a negative answer, or up, which is positive and left, that's going to give us a negative answer. So you're still going to get the same thing. You can work it out and try to prove it to yourself and be more confident. So now that I have this set up, 26/7 and negative 39/12, I can see that my y, the change in y is from 7 to 12, which is a positive 5. So I'm gonna be honest, I'm already glancing over my answer choices, and I'm looking at which one has a y that's changing for 5, and I'm already like, okay, my man right here is already getting my attention because this is the only one. Now it may not be it, because maybe I need to simplify something and it's going to change it, but right now I'm like, okay, just that step helped me out a lot. So what about from 26 to negative 39? We're going down. So we're going down how much? So 26 to 39. So what's 39 plus 26? It's 5 1. Is that 65? Okay, see, this is already changing, right? Because that's a big number, and I noticed that 65, so this is 5 over negative 65. So I already see that 65 is a multiple of 5, so we can reduce this one. Divide by 5 on both the top and bottom. That's 1. 65 divided by 5 is 13, I'm thinking. So let's see, 13 times 5, 5, 1. Yeah, so that's 13. So it's going to be a negative 1 over 13. So, man, at first, that one looked good if I just did that first step. But, man, I'm glad I finished it. And I didn't consider that because negative 1 over 13 is actually the right answer once I see that these can be simplified. So this is not right. This is what I want to be. So use your calculator to do those maths if you want to double check that. But we can do it by hand just as easily. But it's always good to have a second way to check. All right, so what's the slope here? Which of these represents the rate of change of temperature with respect to the altitude? So we're really, again, looking for 2 points if we got a graph. So I'm going to identify 2 pretty good points. Now, they're not going to give you perfect graphs where you can find integers that line up perfectly because that's not real life. So we're going to find some that seem pretty good to us. And I'm going to say, let's go with as close as I can. Let's go with this one. And I'm thinking maybe this one. I'm guessing that's a 10, right? Because they count about ones. So I have 2 points. I have this point here, which is a 7 on my x-axis, and a negative 30. Now don't count the boxes, right? And go 1, 2, 3. I only have 3. Negative 30. So I'll put 3 there. Oh my goodness. So, but negative 30 is what I want to see. Now for this point, let me write that on here actually. 7, negative 30. And on this point, we have 10, negative 50. Negative 50. So 10, negative 50. So the question is, what's the rate of change? Same thing as slope, but they have units here, so they're saying rate of change. Well, from negative 30 to 50, what happened? Well, we went down 20. And what about from 7 to 10? From 7 to 10, we went up 3. So it's going down 20 what? Degrees Celsius for every, this is degrees Celsius if you want to be particular there, for every 3 kilometers in the altitude, 3 kilometers. So which one is more likely? And then they put them in decimal form, so I need to know what this looks like as a decimal. I can estimate pretty easily, right? 20 divided by 3 is almost 7, so it's like 6, 18, you got 2 there. It's like 6.6. So the closest is going, I don't know, it's going down, so this is a negative. The closest answer is not 3, it's definitely not 0 point. There's nothing even close other than negative 6.5. Now again, you can use your calculator, but I want to show you can do these by hand just as easily and sometimes faster. All right, now I told you we're going to look at point slope. So this is the closest to point slope you get. What's the rate of change of the cost in dollars with respect to the number of miles? So the rate of change, this becomes kind of easy to see because if you distribute this 1.5, you're going to end up with 1.5x, and you distribute here, you're going to end up with negative 1.5, and you're going to have a 3.75 you add to it, plus 3.75. Now, and this is why. So really, all of this right here doesn't really matter. That's the y-intercept. So if you're looking at it from a slope-intercept perspective, you're only now looking at this. This is just y-intercept. So this piece here becomes clear that it's just 1.5, $1.50 per mile. All right, I think this is probably our last one. So given a table, actually I may have one more. What is the rate of change of y with respect to x for this function? So we're just given a table, look for the rate of change. We know that this is a line, or it is right there. And that's important because we talk about quadratic, exponential also, and we want to know that are we dealing with a line, because I can just pick any 2 points because it's going to be the same one. I'm not going to even deal with these decimals because I don't have to. I just need 2 points. So I'm looking at these two right here, and I notice that it's going down 9 and this is going up 2. So I got -9 over 2. Easy peasy for sheezy wheezy. All right, here's my last one, and this is another one where the lines don't quite match up and they want you to give the best estimate. So let's do that. Let's find one. I got a point here, so I got to kind of look close, and you might have to look close on your paper too, but I'll try to zoom in. So there's 2 points there. Let's find out what those 2 points are. So this is a, let's see, we're counting by what? 80 by 5s, 85, 90, 90. So that's a, by 5s, we're counting here, increments of 5. That's a 90. And that 90 corresponds to what over here? So let's say counted by 1s, 26, 27, 28, 29. So 29. I may just take my calculator out on this one because we got some interesting numbers. My next point here is, again, by 5s, this is going to be 55 and 26. So we're going down 3. Is that right? Yep, going down 3. And what's happening here? We're going down again from 90 to 55, 35. Yeah, 35. So it's -3 over -35, which is the same thing as 3 over 35. Which one of these is closest to this? So don't be dismayed by the fact that it doesn't say exactly your numbers. So you're trying to get what's best represents, right? It's not going to be exact. Like, this is the best representation, and they make the numbers so far off that you're not going to mess it up too much. I can already tell this is about a tenth. 1 out of 10. So I'm already looking at a tenth. A tenth is 1 out of 10. So that means, if this was 3 and 30, that'd be 1 out of 10. So I know it's not going to be 12 at all. It's nowhere near 12. It's like it's less than 1. And it's definitely not 22. This is less than 1/10 is 0.1. So this is definitely not close. So those two will cancel. This is 700. 700 is 0.07. And this is the closest to a tenth because 1 out of 12 is very close to 1 out of 10. Now, I'm doing that in my head because I understand those numbers, but if you can't, I will go to your calculator, which I'm going to do now, and I would just look at the decimal portions of them, and you can put those numbers in as decimals. 3 divided by 35 to get your decimal. 35. So let's approximate that decimal is 0.08. 1 divided by 12. And if you approximate that, you're going to get, look at that, 0.0857, 0.083. It's clear that your 1 over 12 is the one that's most like your 3 over 35. So that's the one we're going to go with. Hey, thanks for tuning in. I hope you understand slope and rate of change a little bit better, how to find it using a graph, a table, a word problem, 2 points, no matter what it is. You know how to go from standard form to slope intercept form so you can identify that slope. Guys, thank you for tuning in again. I know you're going to do an incredible job. My name is Clayton, the Algebra Guy, and I'll see you next lesson.